Here we go. Oh, got to have my favorite student, good old Anne. Test is made up. I think it's 16 multiple choice-ish questions. And then it's out of, I think it ended up being out of 35. I think you'll finish it with plenty of time. So on the multiple choice, on the written, what can you expect? Some card questions, committee questions, bucket questions, definitely a fundamental count. You know what? I had the 3 quizzes that I've given you in front of me, and I picked a few also from the self-test and a few from the homework where people didn't ask me questions from the homework, and I figured it was because they'd just been lazy and copied the answers. But no surprises on this test. At cafeteria, Chef Dueck created 4 feature meals, 3 drink choices, and 4 dessert choices. The test also is going to go approximately in the same order that I taught you. So, you know what? Number 1 on your test is going to be fundamental counting principles, Scrabble bag, and draw blank. Or here, 1, 2, 3. I have 4 meals, 3 choices, 4 dessert choices. The answer is B. Yes? Yeah. I didn't have lunch. This was a bad question to put on here because I'm starving. How many different arrangements? Again, arrangements is a trigger word that tells you it's a permutation, not a combination. Using all the letters of the word Toronto, Ontario. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's going to be 14 factorial over 3 T's. 1, 2, 3, 4, 5 O's. 2 R's, I already did the O's. 2 N's, I already did the T's, I already did the O's. Is that it? I think that's it. 14 factorial over 3 factorial, 5 factorial, 2 factorial, 2 factorial. What's the correct answer? A, B, C, D, or E? I got D. Sorry? There's 2 N's? I think I got that. I think I have 3 T's. 5 O's, 2 R's, 2 N's, right? I think I got them all. Yep. What's the answer, folks? D. 30,270,240. Now, please bring your formula sheet to the test. I haven't used them much, but it's what we derived all these shortcuts from. So I will give you a couple of questions on them. Which value is equivalent by definition to 100p4? Well, according to my formula sheet, npr is equal to n factorial all over n minus r factorial. So I guess in this, it's going to be 1,000 factorial all over 1,000 take away 4 factorial. But what's a better way to write 1,000 take away 4? Oh, never mind, it's sitting there. B. I could also have put a 996 at the bottom there too. How many 3-letter arrangements of the word symbol are there? I'm going to use the shortcut, 6p3. Or you could also draw 3 blanks and say 6 letters, then 5 letters, then 4 letters. Actually, I can do that one in my head. 120, none of these. Is it E, none of these? From a regular deck of 52 cards, how many 5-card hands have exactly 3 hearts and 2 clubs? Bucket. Card questions are almost always going to be combinations unless, Jake, it's obvious. If they say the first card is, the second card is, okay, then the order matters. But if they just say in the hand, I've played poker, you don't care when you got it, you only care if you got it. So it's going to be a bucket. What's the bucket going to look like? It's going to have hearts, clubs, and you know what? I'll call the rest others. How many hearts are there? 13. How many clubs are there? 13. How many others are there? I guess 26 left over because it's got to add to 52. And I want 3 hearts, 2 clubs, no others. Mathematically, then, it's going to be from 13 choose 3 and, from 13 choose 2 and, from 39 choose 0, although from 39, Mr. Dueck, 26 wouldn't have made a difference, though, because 26 choose 0 was 1. What'd you get for an answer? A, B, C, or D? Should be one of them, I hope, isn't it? A? 22,308. Number 6. Wow! Physics students, I think I'm going to dulp. What does dulp mean? I'm going to draw a little picture. It's a 6 by 6 square. Okay. There's the square. And then to make it 6 by 6. Yeah, the tongue helps. Okay. It says I start in the northeast corner and I get to the southwest corner. It looks like every one of these routes is going to require me to go, I guess not right this time. You know what? Since they said directions, I'm going to go west 6 times and south 6 times. The total number of routes is going to be 12 factorial over 6 factorial, 6 factorial. The total number of ways that I can travel, option prob, is going to be 12 factorial divided by bracket 6 factorial, 6 factorial. Syntax error. Oh, I forgot the times. Okay, I got 924 different ways, but then it says if I walk a different route each day, about how long will it take? How would I find out how many days this will take me? Take that 924 and do what? Now I'm going to go divide by 365 days per year. Oh, you know what? Pretty close to 2.5 years, a little more than 2.5 years. So that gives you an example, Logan, of a kind of twist I can throw at you. I can take a pathway or any other combinatorics problem. And how long? How many? Nice twist. Number 7, in how many ways can 4 women and 3 men be seated on a bench if the men and women must alternate seats? Oh, I think I can do this by drawing a blank. I'm good at drawing a blank. Seven people grand total. If I want to alternate genders, do I have to start with a boy or do I have to start with a girl in this question? Girl. Have to start with a woman. How many choices do I have for the first female?
4.
Skip, then how many? Skip, then how many?
2.
Then? How many choices do I have for the first guy?
3.
Then?
2.
Then?
1.
And as a shortcut, I guess I could have gone 4 factorial, 3 factorial. I see that in hindsight. That's probably what I would type. 3 factorial is 6. 4 factorial is 24. Is the answer D, 144?
Yes.
Number 6. What is the number of arrangements of all the letters in the word banana if each arrangement must start with an A? Ooh. Okay. Have to have an A there. Put it there. I guess that's going to leave me with because I've used one A up at the front. Is that right? So it's going to be 1 times, how many letters are left in my Scrabble bag?
5.
Over any repeats? 5 factorial divided by, you know what? 2 factorial is 2. The bottom's a 4. 30? D. D. Okay. Open-ended. Number 2 is particularly nasty. If you had trouble with number 2, don't freak out too much. Number 1, How many 4-digit odd numbers are possible using? Okay, so there's my Scrabble bag. And if they want to, how many digits? This is fundamental counting principle. Brendan, I'm going to draw a blank. 1, 2, 3, 4. Now it says it has to be odd. So if it's odd, we're really talking about what it ends in. I guess in this example, it has to end in a 3 or a 5 or a 7. Right? Right. How many choices do I have for that? 3. And repetition of digits is allowed. So I guess that means we throw it back and we're back to our original Scrabble bag. How many choices do I have for the first digit? Careful.
5.
Why not 6? Okay, can't start with 0, so I have 5. Throw whatever number I picked, shake it up again. How many choices do I have now? 6, then?
6.
Okay, so it's going to be 30 times 18. Can I do that in my head? Yeah, sure. 540? Yeah? I can do the math in my head because I know my times tables. Okay, what if repetition of digits is not allowed? Going to start out the same way. Now I'm probably going to draw on my, you know what, instead of drawing a Scrabble bag, I'll just cross out numbers up there. So it has to be odd, which means I have to have 3 choices. Let's suppose it was a 7. There's my specific example. How many choices do I have for the first digit now? Careful, I don't think it's 5. Why 4? So, Mark, let's suppose it was a 2. How many choices do I have for the next digit? Careful. I got now all are back in play. 4, then 3. It's going to be 16 times 9. 144? Or no, yes? Yeah. 144, 1 mark each. We're going to come back to question 2. I'm going to save it for last. Number 3. 1, 2, 3, 1, 2, 3, 4. It's going to be 7 factorial over 3 factorial, 4 factorial, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial all over 6 factorial, 3 factorial. It's going to be whatever the heck that is. So if you have that written, that gets you 1 mark. By the way, in a wonderful coincidence as a shortcut, this is really 7 choose 3 and 9 choose 6, if you're looking for an even shorter way to type it, which I'm going to use. 7 choose 3 and 9 choose 6. Should get 2,940. I would probably give you, well, 2 out of 2 if you got the right answer. Otherwise, half mark if I saw that, half mark if I saw that, a half mark if you knew that you multiplied them and didn't add them, and a half mark for the answer. At least. That's going to mean 3 or what? Or, oh, it says you're choosing a committee of 5 people. So I know there's 10 girls and you keep, nope, it says cap it at 5. Okay. Does the order matter here? Does it mention positions like president, vice president, and secretary? Then bucket, especially since I noticed 2 subgroups. So my bucket's going to look like this. Here's my bucket list. Girls, boys, 10, 8, and the first time it's going to be 3 and 2. So it's going to be 10 choose 3 and 8 choose 2. Or the next time it's going to be 4 and 1, 10 choose 4 and 8 choose 1. Hopefully I'm convincing you that that bucket is worth the bang for the buck. To draw it once really, really helps you. I still see a few people trying to do these in your head. I can't do these in my head. Not and keep everything straight. I almost always make a mistake. And 5 and none 10, choose 5, and 8, choose none. 10, choose 3, and 8, choose 2, or 10, choose 4, and 8, choose 1, or 10, choose 5, 8, choose 0 is 1, so I'm not going to bother writing it. Do you get 5,292? Yep. So if you got that, 2 out of 2. If you got that wrong, I would probably give a half mark if I saw that, a half mark if I saw that, a half mark if I saw that, and a half mark for the answer. Hey, let's play cards. How many ways are there to form 5-card hands if every card is a club? This looks like a job for a bucket. Club, not club. 13, 39. 5 clubs, no others. Mr. Dueck, why didn't you go times 39, choose 0? Because it's 1. Is it 1287? Yeah? That's called a flush, a club flush. Again, how many suits are there? That's how many ways there are to get a flush in any suit. And if you want to know the probability, divide that by how many 5-card hands there are. 52, choose 2. That's the odds of getting a flush. No, Mr. Dueck, that was wrong. 5148 divided by 52, choose 5. That makes way more sense. And you get 0.00198, a pretty small number. It's a good hand. Exactly 3 clubs in the hand. Okay, I guess that's going to be... Oh, I can use the same bucket. Except this time, 3 and 2. 13, choose 3, and 39, choose 2. 13, choose 3, and 39, choose 2. 211926. 1 mark for each of those. Oh, C. That's going to mean 3 or 4 or 5. Grayson, 3 clubs I just did. 211926. And 5 clubs I did earlier. 1287. You could rewrite them, by the way, but I cleverly noticed that I'd done half of the work, more than half of the work already. So really, I just got to get 4 clubs, which is going to be 13, choose 4, and 39, choose 1. 211926, or 13, choose 4, and 39, choose 1, or 1287. Do y'all get 241,098? Again, if you got the right answer, 2 out of 2. Otherwise, since that last line has 4 different things, a half mark for each thing. Turn the page. Pamela! I didn't know you were a disc jockey. Yep. And Pamela has chosen 10 songs to play for a school dance. Oh, excellent. She creates, this tells you that I typed this question up about 7 years ago. 1 10-song compact disc for these songs. Oh, sorry. Boys and girls, once upon a time, we used to keep music on these little silver discs. Music used to be kept on a physical object, and you would carry it around with you. By the way, those might be coming back. I just saw about a month ago, scientists in Australia using normal DVDs found a clever way to up the storage rate from what it is now, which is about 700 megabytes, about 0.7 of a gigabyte, to, I kid you not, 40,000 gigabytes, which is, holy smokes, huge. Well, it'll hold. It would basically hold about 50,000 HD movies on one DVD. So if they can mass produce it, that may be an issue. And it had to do with adding a second laser to the DVD and looking at how they crossed, and stuff. It was quite clever. Anyways, keep an eye out for that. If they can make storage like that, then DVDs will come back in vogue again, because that's a lot of storage. How many different ways can she keyword arrange? I think this is going to be 10 factorial, which oddly enough we did earlier. What was 10 factorial? Brendan still has it on his screen, I bet you. Okay, what's 10 factorial? what?
3,628,800.
800?
Yeah.
So you can think about, by the way, on your MP3 players, when you hit your shuffle button, I assume most of you have more than 10 songs in a playlist. It's really quite astronomical, the number of different random playlists that could possibly be generated. The only problem is the iPods or the MP3 players, any of them, don't truly do random playlists because they can't do a random number. They do what's called a pseudo-random number. So this math isn't quite accurate for electronic devices. A computer can't make up a random number. It's impossible. Computers are based on patterns and algorithms. You can't get a random number from an algorithm. Usually what they do is they have a clock timer running in them that ticks off time, I think, by milliseconds. And so whenever you hit the random button, they take that time right then, they run that through an algorithm, and then they do something else. And but even like the CIA and the NSA have a great deal of difficulty generating random numbers for encryption keys. Because computers can't generate random numbers. In fact, I think what the CIA and the NSA actually do, I kid you not, is they look at weather patterns, which are random, and they turn that into some kind of a numerical extrapolation. Nerd trivia over, but yeah. Pamela realizes the first 3 songs are crucial for setting the tone. She's a good DJ. She chooses 3 songs from the original 10. Math is wonderful. Oh, Pamela. The never-ending algebra problem? Oh, Pamela. And you plus me equals us. Oh, look at you, you little romantic devil, you. How many ways can those 3 songs be placed at the start of the CD? How many songs? I guess I can mix those up. 6 ways. Now, I wasn't sure if they wanted me to include the rest of the CD, but then I read part C. It says, how many ways can she burn the compact disc if these 3 songs must be at the start of the CD? And I went, oh, okay, now I think we're going to include the rest. So we have this weird Scrabble tile with 3 songs, or 3 factorial. How many songs are left? It's going to be 3 factorial and 7 factorial. And I get 30,240. Why did I make that one worth 2 marks? I don't know. If you got it, you get 2 out of 2. Otherwise, I'd probably give you a half mark if I saw that, a half mark if I saw that, and then 1 mark for the answer. Why did I make B worth 2 marks? I don't know. Apparently, I thought it was going to be tougher than... Anyways. Given the word mathematics, okay, now we're getting in some tricky ones. How many 11-letter arrangements can be made if the final 4 letters must be vowels in any order? So I think I'm going to go kind of with my Scrabble bag sort of analogy, and the final 4 letters, A, E, A, okay, it's got to be this. And that leaves me with M, T, H, M, T, C, S. Okay, so the final 4 letters must be the vowels. I guess the final 4 letters is going to be 4 letters, but there's 2 A's. That's the final 4 letters. What does that leave me with? 1, 2, 3, 4, 5, 6. That leaves me with 7 letters with 2 M's, 2 T's. So there's the front 7, and then the final 4, because A does appear twice. This is, by the way, this is about as tough as I can throw at you. If you got this, well done. And even if you didn't get it, hopefully you go, oh yeah, I can see how he got that. It's going to be 7 factorial, 7 factorial divided by 4, because that's what 2 factorial is, times 4 factorial divided by 2, because that's what 2 factorial is. 15,120. How many of you got that one okay? Nice. That's a tough one. What did I say, 15,120? Yep. If the 4 vowels must always be together in any order. Okay. Now I guess I can use the same Scrabble bag. First of all, let's zoom out. How many tiles are there in here? One, two, three, what? 8, because if they have to be together, that's one funky Scrabble tile. So it's going to be over 2 M's, 2 T's. Now that's how many ways I can mix those up. But how many ways can I mix up the funky Scrabble tile? I think it works out to 2, but yeah. There's the notation. I think now, since I didn't say it had to be at the end, what we're really saying is, you know what? You can mix it up 8 extra ways. So it's going to be, 8 divided by 4, because that's 2 factorial, times 120,960. By the way, I would probably give you half mark for that, half mark for that, half mark for timesing, half mark for the answer, and same with the previous one. We haven't done the mystery question yet. Example 2. So I'm not going to give you one of these to algebraically solve on your test because I don't think I covered it well enough. However, first of all, let's clue in. You could probably just guess. How about 4 choose 2? How about 5 choose 2? Is it 8 choose 2? So that gets you 1 mark if you got the 8. But what was the word that I bold-faced? So here's how you would solve this algebraically. N choose 2 from my formula sheet really means n factorial all over 2 factorial n minus 2 factorial. That equals 28. That's right from my formula sheet. That's the definition of choose. By the way, on the bottom left, what is 2 factorial? What is 2 times 1? 2. So in the next line, I'm going to drop the factorial. It isn't that I actually dropped it. I evaluated it. I'm going to get all my factorials to the same side, which they are. Any non-factorial, I'm going to get all my n's to the same side, all my numbers to the other side. In other words, I'm going to go times by 2, times by 2, and that's going to cancel. I'm going to get Taylor, I can't just cancel out a factorial. What I can do is expand one of these so that I get the identically matching factorial term. I got an n, I got an n minus 2. Which one's bigger?
28 times 2.
56. Thank you. After bragging about doing math, that was pretty bad. I can't do math in my head. I can't do math in my head. Okay. What's bigger, n or n minus 2? I'm going to expand that. On the next line, I would go n minus 1, n minus 2. I would stop there. I still have an n minus 2 factorial in the bottom. And I would say to myself, self, they cancel. I have n minus, in fact, now what I would do is I would also do distribute, front door bomb, whatever your heck your math teacher called it. distribution, expand. It's n squared minus n equals 56. What kind of an equation is this? It's a quadratic. How do I know? Because Mr. Dueck did a lesson on quadratics at the beginning of the year. It's got a squared. How do I solve a quadratic? I have to make it equal to 0 first. I would go from both sides. And I'll get n squared minus n minus 56 equals 0. Now what? You could quadratic formula, but it turns out, Matt, this will factor. They always will, because I have to give you a whole number for n, because I can't have, if we're talking about letters or objects or cards, I can't have 4.6 cards. Doesn't make any sense. So it's always going to work out evenly. I'm looking for two numbers that multiply to negative 56 and add to negative 1. It factors into n minus 8, n plus 7 equals 0, which really means as roots. Who have I been rejecting in this class? Jake? Reject, much like when you ask a girl out on a date, right? It's always been an athlete for years. And again, it's a dumb way to help you remember. Why do I reject that? Because you also can't have negative 7 cards. And remember, n is the number of objects, which was in the original equation. You can't have negative 7 cards. Now, that's the algebraic method. If you have this, that gets you 1 mark out of 4. If you rejected that, that gets you a half mark. Then I would probably go something like this. I would give you a half mark if I saw that line, a half mark if I saw that you times by 2. I would give you 1 whole mark for getting to that blue line right there. So right now we have 1, 2, 3, and I would probably give you, oh heck, a half mark for the factoring. Something like that. Kind of, sort of. There's the 4 marks. Can you please give yourself a nice clear score out of 32?